Hello friends, welcome back. I am Rajnesh and today we are going to understand how to handle the packets using IP tables. IP tables is a packet filtering and packet altering application which is available on all the Linux distros. So the question comes, why do we want to filter the packet? It simply means if you are talking about your server, you want to restrict access from a specific IP address or to a specific service by a specific set of networks. Packet filtering means a simple firewall that blocks and allows different set of networks or access to different ports and IP addresses. The second part is mangle or packet alteration. You could modify the packet also. Why do we want to modify the packet? The reason could be you want to modify the TCP headers associated with it. It could be time to live, type of service. You could mark a packet and implement different quality of service to it. You can implement a traffic shaping based on this mark. So let's talk about these chains. If you are talking about this rectangle, it says your firewall. A network is outside your firewall. So finally what is happening is this is your internet or any external network. As soon as the traffic comes to your firewall, first of all it enters the pre-routing chain. As the name suggests, it's pre-routing. It simply means before the destination or before the routing decision is made for a packet, the packet goes through the pre-routing chain. Here you can modify the TCP headers by using mangle, or you can modify or do network address translation. Why do we want to do network address translation? You may have a server inside your LAN that may work as a web server for public and that doesn't have direct access to the public IP address. So in that case you can modify the address associated with this packet so that any packet coming for the web server goes to the internal web server. We'll see an example of it. After the routing decision is made, it goes to the forward chain and then to post routing. Forward chain simply means any packet which is coming from the external network and going to the external network, coming from one network or IP address and going to another network or IP address. In this chain you can pass it through the table which is mangle, which says you are modifying TCP headers. The other could be related to filtering, where you can block a specific network from passing the traffic through this forwarding chain. There and finally, if you are talking about the let's talk about the input chain. Input chain simply means any traffic that is coming from any network, but the final destination of the packet is local machine or your firewall. In that case, it goes through the input chain. It's present in the tables mangle and filter. Filter means you are filtering, blocking, or allowing access. Mangle means TCP header modification. Now, any traffic that is originated from your firewall and goes out to a different network goes through the output chain. Output chain is present in the following tables, which is mangle, network address translation, and filter. Filter used for blocking or allowing a particular network or IP or port. Network address translation for, as the name suggests, network address translation, and mangle for TCP header modification. So output says any traffic originated from the firewall and going out to any IP or network. And finally, we come to post routing, which simply means the routing decision is already made. And finally, you can modify the source address from which this packet was coming to a different IP address. Why do we need it? One scenario is you have an internal network in which you have a single IP address, single public IP address, and multiple local IP addresses. You want to share internet among all these LAN machines. You may have to use post routing where you change the source address for any traffic going from the going through the firewall which is coming from the LAN, and that will be masqueraded to the public IP address of your firewall. And second is, if you want any traffic going from your web server, SSH, or any other server to make use of a different public IP address, you can make use of it. So to recall, input chain means any traffic coming from anywhere to the firewall. Output chain, any traffic originating from the firewall and going out. Pre-routing, any packet coming from the internet as soon as it enters the NIC, and before the routing decision is made, it goes through the pre-routing chain. And here we generally do destination network address translation, or DNAT, because the routing decision is not yet made till the packet reaches this pre-routing chain. Post routing, because the routing decision has already made, the destination of the packet has already been defined. Now our objective could be to change the source address, or source network address translation, or SNAT, forwarding any traffic coming from a network and going out to a different network. So simply means which is passing through this firewall. Now, coming on to the tables, the default tables that we generally make use of are filter, NAT, and mangle. Filter means you are filtering the traffic, allowing or blocking access to a port, or from an IP address, or from a specific port, or to a specific port. By default, in the filter table, we have three chains. One is input, other is output, and third one is forward. As we have already discussed, input, any traffic coming to the firewall, output going out of the firewall, and forward passing through the firewall. NAT, network address translation. It can be implemented in pre-routing, and in pre-routing, as we already discussed, because the routing decision is not made, we can change the destination address of the packet and route it to a different network, or different network inside our LAN. So this is actually destination network address translation. And post routing, because the routing decision is already made, the destination is already specified, you can change the source address which goes to SNAT. So post routing is SNAT, and it can be implemented in output also. Mangle means TCP header modification, and it's present in all of your chains. Basically, the target which are different for the mangle are, you can mark it and implement a traffic shaping on it. You can modify the time to live and type of service. Now, if we try to understand the IP tables structure as we discussed, first of all, there are multiple tables. Defaults are filter, NAT, and mangle. Corresponding to every table, we have multiple chains. By default, for filter, input, output, and forward. So input, output, and forward could be there. I just missed it. So in every table, we have multiple chains. Input, output. Corresponding to every chain, we have a set of rules. So these rules are considered or evaluated on the basis of their number. So it starts from rule number 1, 2, 3. If rule number 1 is matched and the traffic is accepted, it will not be evaluating rule 2 then. So we have to be very cautious when implementing these rules and the location of the rules that we have to define. So in every table we have multiple chains, and corresponding to every chain we have multiple rules. Now, coming on to the targets. We have a packet, we have now checked out for certain rules. What happens if a rule matches? We can accept it, means that packet is now allowed and no further processing is required for this packet. Drop drop that packet which matches a particular rule, and no further processing will happen for that because the packet is already dropped. Log is a different rule which says log a particular packet that is matching certain criteria to the syslog or varlog messages and continue processing the next rule. Why do we want to continue processing? Because what it did is simply logging. Simply logging. No action was taken whether it's to be accepted or dropped. Now, other action could be reject, which, sorry, uh, okay. Other action could be to reject. Now, the difference between reject and drop is that in drop, the packet is simply dropped and the machine that is responsible for sending this packet is not notified. If we are talking about reject, it notifies the sender of the message that you are rejected for this packet, specifying the reason. It could be any error message that you specify. DNAT, you are modifying destination network address translation. So you are rewriting the destination address. You make use of the syntax minus minus to destination. Source address translation, you modify the source of the packet to a different IP address. So you make use of syntax minus minus to source. Masquerade means that is going to actually mask itself and going to make use of a default IP address or the default public IP address of your firewall when going out. So it does source network address translation. By default, the source IP address is the same used by the firewall interface. It specifies a source port to which the original source port can be mapped. So if you talk about the scenario, it's simple. You have a LAN, you have a set of 10 or more PCs, you have single router with a single public IP address, and you want to use or access internet from all these 10 machines. You'll make use of masquerading. General IP tables command switch. So minus T says which table for which a rule is to be added or deleted. Minus, it could be your filter table, NAT or mangle. Minus J, what is the action to be taken, whether it's to be dropped, rejected or accepted or netted. Minus A, append at the end of the chain. Minus F is to flush that chain. Flushing means cleaning up all the rules or deleting all the rules from the chain. Minus P, you can specify the protocol type, TCP, UDP, ICMP. Minus S, the source IP address. Minus D, the destination to which the traffic has to go. Minus I is the input interface from which traffic is coming or the packet is coming. Minus O, the output interface through which this packet is going. Now minus minus S port is the source port from which the traffic is coming. Minus minus D port is the destination port to which the traffic is going. Minus minus SYN for SYN packets. You can specify multiple ports in the same rule by using M multiport and minus minus S ports or destination ports depending on the source ports or destination port that you want to specify. And finally, it could be based on the state of a packet. The state of a packet could be established, means the connection is already established and the traffic is flowing through it, and you get a packet corresponding to the same established connection, then it comes under the state established. New when a new connection comes from a new IP address which is trying to create a new connection related, it's the packet is related to the traffic which is already coming to the server. Invalid, the packet couldn't be identified. The reasons could be different. It could be due to insufficient system resources or ICMP errors that don't match an existing data flow. Now, the kernel modules associated with it. If you want to implement Iptables NAT, this module should be loaded. If you are talking about connection tracking or you want to rate limit your traffic, you need to have contract loaded. And if you are talking about FTP, as I suppose you might be knowing that FTP, instead of making use of single connection, makes use of two connections. One is for command and other is for the flow of data. For command, it makes use of TCP21. For the flow of data, it makes use of port UDP20. So the second connection may be established by your client machine or by the server itself, depending upon whether the server is active in passive or active mode. If the FTP server is acting in active mode, the server will initiate a connection from itself to the client for data. If the server is acting in passive mode, it will tell the client, connect to me using this port. So if you have implemented Iptables and you are implementing FTP server on your server, you need to implement IP contract FTP, or you need to load this module. If your FTP server is behind NAT, you need to make use of, or you need to load the module NAT FTP. Now this is the scenario that we have in our lab. This is the internet, which is network 192.168.1.0 in my scenario, and the LAN is using 10.0.0.0/24 network, behind which these machines are there. The lab scenarios that we are going to implement is, first is these PCs, they should be able to access the internet, which simply says I am going to implement a rule which is corresponding to the post routing and which is going to masquerade any traffic from this network so that it passes or makes use of this IP address of the firewall or the public IP address of the firewall. The second rule is we are going to implement a web server in one of the PCs, and for that, any client that tries to access the browser is going to make use of some public IP address. It could be the IP address of the firewall, and when it tries to hit port 80 on this firewall, it will actually be forwarded to the PC1, and this time we are going to make use of pre-routing chain, because before the routing decision is made, we need to modify the destination address so that it reaches PC1. SNAT. Okay, the third scenario is going to be SNAT, where I am going to modify the source IP address of this PC1 whenever it tries to reach the internet. So basically, in other words, I could say whenever I am trying to reach the internet, I am going to make use of a public IP address attached with it. So assigning a public IP address to a server inside LAN. So here we finish up with the lab. Now finish up with the presentation. Coming on to the lab now. So okay. Let's understand the scenario. We have one machine infra, which is any of your machines which is present on the internet, because I am simulating 192.168.1.x as a network which is acting as an internet. We have installed CentOS 6 on FW2-in, which is going to work as a firewall on which we are going to implement some rules and test out the scenarios. This firewall has two interfaces. One is 192.168.1.240 and other is 10.0.0.240. This is your public IP address and this is your internal IP address to which your India office is connected. Now there is one office in India or any country or any city that has the IP address, this one, 10.0.0.2. Now let's start with the scenarios. Here, if you want to understand them, this is my firewall in India office. This is one of the stations in your India office, and rest all is internet. Specifically this infra server, this is an internet. My desktop is on internet, and 192.168.1.x is considered as an internet for our lab scenarios because I don't have multiple public IP addresses at my home. So let's create sessions with these machines. This is my firewall, this is my station, clear it, and this acts as any machine in the internet. Okay, so first thing is station1.in. Any machine, desktop or server which is inside your LAN which that wants to reach to the internet. Okay, first of all, let me see the configuration, routing configuration. If config, it says I have a single IP address which is 10.0.0.2 and my default route is 10.0.0.240, which has to be your firewall. If config eth1, so this is the IP address of your firewall. Fine. So any traffic that is going through this India station is going to go through this firewall. Okay. Let me first start with the filter table. So let me install Apache web server on it. On the firewall itself. Okay. I created a file index.html which has nothing else but the hostname of this machine, which is going to be fw1.in. The reason being, whenever I try to access the web server, I can assure myself that I am hitting the web server of firewall. Now, elinks is not there. Elinks is actually your console or ncurses based browser. Elinks http 10.0.0.240 and it says no route to host. Okay, can we ping it? Yes, I can ping it. Can I hit port 80 for the browser? I cannot hit because iptables -l -n, and here, okay, let's have a generic look into the iptables. So what I did is iptables -l is to list all the chains by default for the table filter, and -n do not try to resolve the IP address by name. So here if I see, it's displaying me the filter table and there is input chain, forward chain and output chain. In the input chain it says it's actually not complete. -v is for verbosity. Here we see the number of packets, the number of bytes that have been received in this chain, in this input chain corresponding to this rule. Okay, there was one more thing, line numbers, to display the line number. So actually the rules are implemented in the same numeric way. Rule number 1 is evaluated first, then 2, then 3, then 4. If 2 succeeds and it says accept or drop, rule 3 will not be checked. Okay, so number of packets coming for rule number 1, number of bytes come, except in case the state is related or established. Okay, so it says allow ICMP access from any IP address, allow any traffic which is coming from localhost, except TCP traffic coming to port 22, and then reject all. So if you see to the rules, you are not allowing port 80. So what I'm going to do is, just before reject, I can create my custom input chain. So here you can see rule number 5. So what I'm going to do is, first of all, let's create a new chain and name it as my input chain. So now if you type this command here, you can see there is one more new chain which is my input. But now the traffic is not going to get into this chain because it doesn't know when the traffic has to go to it. Now you need to specify at some location. By default you have 3 chains which are evaluated: input, forward and output. So I'll tell it, whenever traffic comes to an input, before getting rejected, send it to my input. So how do I do it? Iptables -I input 5 minus j means send it to my input chain. It will say at rule number 5, in input chain add a rule which says send the packet to my input. Now if I again see the rule, it says here it sends the packets to my input chain, and now whatever rules in my input are there, they will be evaluated, and after that it will come back to the 6th rule and it will reject. So my objective is to allow traffic from any network or from this specific network or IP address to access the web server. So what I'm going to do, iptables -I or -a, doesn't matter. -I is rule number is going to add as rule number 1, and -a is going to append as the last rule in that chain. Because this is a new chain, so doesn't matter. -s 10.0.0.0/24 -p tcp -d port 80 -j accept. So this says any traffic coming from the source network 10.0.0.0/24 hitting port 80 on this server, which is firewall server, it's to be accepted. And here it comes, the rule is added. Now after you are done, you have to type the command service iptables save. Now what happens is, you have a file /etc/sysconfig iptables that will be updated for the new rules that you have added. So here you can see append this rule to my input. Previously, before you didn't save it, it was not there. So after every modification to the firewall, make sure that you have saved the iptables rules. Fine. Now as I have allowed the traffic from this India office or India LAN to hit port 80, let me see if I can successfully do telnet on port 80. Yes. E-links, and I can see that this is the firewall that I can access. This is the web server on the firewall, or it'll just display what we have in this file. So now this is how the input chain works. Or mm, let's talk about another scenario, uh, or let's have an example about output chain. Okay, I forgot about one thing. If you talk about input chain, here you can see policy which is accept, which says by default in input chain accept the traffic. In case your traffic doesn't matches any of the criteria, accept the traffic. But as we have the last rule which says reject, so everything else is rejected. If you talk about policy forward, it says accept everything by default, but you have a rule which is present in rule number 1 which says any traffic going from which is forwarding through this firewall, block that traffic. Here, okay, if you talk about output, the policy says accept and there is no such rule, which simply means any traffic going out anywhere, whether to internet or internal LAN, that will be allowed without any restriction. So, and generally, as a rule of thumb, you allow outgoing access, or you allow the traffic from any PC to outside. Only the internal traffic is blocked. Okay. If you want to see an example, I think I have the web server on station 2 also. Yeah, I have it. So if I try to access it, let me install E-Links on the firewall also. Okay. Okay. The reason is because if you talk about, make sure that whenever you are listing, make use of capital L minus n. Here we are blocking the incoming port 80, so that's the reason it's not able to open. Okay. uh, E-Links HTTP uh, google.com. You can access any website, or because it's allowed. Output chain is allowed by default. So okay, this is my machine in internet, any machine in internet. So telnet 192.168.1.205 389. Okay, telnet is not there. Why I'm running this is I just wanted to show you. mm, TL. Okay, so 22. So here I can see that I can connect to port 22 on infra server because this is allowed by the input chain of infra, and it's allowed by the output chain of firewall. If I want to block this traffic, what I'm going to do is iptables minus a output minus p tcp minus minus d port 22 minus d 192.168.1.205 minus j drop. So what this rule is going to do is any traffic going through the output chain to port 22 in this infra server will be blocked. So this is how we add rules in output chain. Okay, here you can see one rule in it. So okay, there is one option which is -f, which says flush a particular chain. So if I type the command -f output, it is going to flush or clean up the chain. Now here you can see the output chain is now cleaned up. So this is -F that it does. Okay, now let us talk about configuring this firewall as a router. The first part that we need to do to configure it, okay, as a router is to enable IP forwarding. One option is you can just try to grab forwarding, or in /etc/sysctl.conf you can see that by default TCP forwarding is disabled, means the traffic coming in from one interface and going out to the other interface will always be blocked. So first thing you need to do is you need to enable IP forwarding. If you don't have this option in your sysctl.conf, you can try to grab the same IP_forward in sysctl, and here it says it's 0. So first of all, let's make it permanent. sysctl.conf and enable IP forwarding. sysctl-p to reload the sysctl, and now if you try to grab IP forwarding, this is enabled. Now any traffic going through one interface of this router can come out of the other interface. If we talk about this firewall, we have multiple interfaces: ETH0, ETH1, ETH2. ETH0 colon 1 down, I don't need it, I'll add it later on and will show you why it was added. Okay, so TCP forwarding is enabled, but till now you can see that in the forwarding chain it rejects any traffic. So we need to allow the traffic from our internal network if we trust it, and of course if it is our internal network we trust it. So iptables -I forward -s10.0.0/24 -j accept. This rule says add rule number 1 in forward chain, which says any traffic coming from station to from India network, which is 10.0.0.0/24, allow it, and any traffic that is going back to India office, let's allow it. Or you can just allow restricted traffic which goes inside or into your India LAN. Now you cannot still ping it, but we have implemented two things using sysctl. IPv forwarding is enabled, -t filter, which was by default, -l forward, you can specify a particular chain, -n, and here you say that it's allowing the traffic which is coming from internal network and going anywhere, the traffic coming from anywhere and going to internal LAN, which is allowed. Now the first thing, or any public IP address, for example 1.205, we cannot even ping it, right? The reason being, I don't have a public IP address or an IP address in the network 192.168.1.x. In case I want to reach the public IP address, or say any actual public IP address, I need to have some IP address to which I can masquerade myself. As we had a talk in the presentation about masquerading, so first scenario is implementing internet access in India Office, which is 10.0.0.0/24. So first thing is, in the forward chain we allow the traffic from India LAN and to India LAN. We have implemented sysctl, so IP forwarding is enabled. The final thing is, if we want to have internet access inside all the stations in India, we need to do source natting, which says IP tables minus t nat. Let me have a look into the rules that are already there. If I talk about my nat table, there is no such rule as of now. So I am going to add a rule in post routing chain which is coming from the network, my internal LAN, and going out through the interface ETH0, which is my 192.168.1.240 interface. I'll show you. Minus J masquerade. Okay, let's try to understand this rule. It says add a rule in the post routing chain of the NAT table which says any traffic coming from India office going out through ETH0 interface, that should be masqueraded to the public IP address of ETH0. If config ETH0, and here we can confirm that this is an IP address which is corresponding to the public interface of my firewall. But still we cannot ping 4.2.2.2, or I think we cannot ping any IP address. Okay, so right now here I can see that we are able to reach to 192.168.1.x network, which we previously were not able to. Let's try to reach to the internet if we can, and here you see we are now able to reach to the internet. Or if I just try to ping yahoo.com, it succeeds now. So what actually was done, just to recall, okay, after the rule has been implemented, it will be a good practice to do service IP tables. Okay, before that I'll show you /etc sysconfig and IP tables, and here you cannot see any rule corresponding to post routing that we just added. Here here we have the rule corresponding to post routing, that's not present. So service IP tables save, and now you can see, okay, here my input forward, and here you can see the route corresponding to post routing. And if we just move to the previous, before, just before we saved it, okay, let me just increase the size of it. So here was the status of IP tables: input forward output, nothing like NAT. After that we did IP table saved, and we can see corresponding to post routing there is a rule corresponding to this masquerade which were not there previously. Okay, so finally, just to recall, what we did is we have added a rule in the post routing. Why post routing? Because the decision regarding the destination is already taken. When the traffic is coming from here, I am trying to ping yahoo.com, the traffic definitely has to go to yahoo.com. But the only thing that is to be modified is the source address. Why the source address? Because if we are talking about the source address 10.0.0.2, It's not known to the internet. So what happens when yahoo.com tries to respond to my request over this IP address 10.0.0.2? That's an internal network, and the traffic will not be able to reach back to your station 2. So what actually is happening by the addition of this post routing rule? You say any traffic coming from the India station, masquerade it to the public IP address of firewall, which is 1.240. Okay, so this is how it works. Just as one more example, I'm trying to hit telnet 192.168.1.205 on 22. Netstat minus PANT grep 22. So what I wanted to show after using this telnet command is from where the connection is coming from station 2. If we are talking about infra server, this is any server on public IP address. So my objective is which is the IP address with which the traffic is coming from station 2. And here if you see, okay, let me create one more session for station 2. Netstat minus PANT grep 22. Some mistake, sorry, it was actually 3. So here you can see that there is a connection from the port 57093 to 1.205 on port 22. Fine. If we talk about the infra server where we are hitting this on port 22, we can see that the requests are coming from 192.168.1.2, 1.2 and 1.240. So if we are talking about 192.168.1.240, this is the actual IP address that this is the actual connection that is established by station 2. Instead of using 10.0.0.2, this is using the public IP address of firewall2.in. Okay, so if netstat minus PANT grep 22. So if we try to grep it over here, you cannot see something like that. Iptables take care of it. So okay, 192.168.1.240, we have one connection, fine. Now if I try to do 192.168.1.205 and okay, so I can see that the connection is okay. I actually grabbed only port 20. So here I can see there is one more connection to port 80 from this IP address 192.168.1.240. So whatever connection I am trying to make from my station 2, it or any station inside India network that actually takes the IP address of firewall 2 or the firewall, which is 192.168.1.240. So this is how masquerading works. Now let's come on to the next scenario, which says my web server is in my LAN and which doesn't have a public IP address. So this is some machine in the internet and this is station 2 in India LAN, which is going to work as a web server from the internet also. So what I am going to do is, first thing what I need to do, this is any machine in internet. What I'm going to do is I'm going to hit whether it's the IP address of firewall or any other virtual public IP address associated with it. I am going to hit the firewall on some port, and that is going to forward the request to station 2. So that's actually the destination network address translation. So let's try to open it first. It says no route to host. Fine, because Apache service is right now stopped on it. Let me start init.d httpd start 10.0.0.2. Okay, fine. The web service is now working fine on it. And in the input chain, just before you are rejecting the traffic, I am going to add a rule -i input rule number 5 -p tcp -d port 80 -j accept. So it says I'm going to work as a web server, so any traffic coming for me on port 80, allow it. Fine. So elinks http 10.0.0.2, it works fine. It should work fine from this location also. Here you can see that I can open it fine. Now the objective is this web server is going to be accessed from the internet, like from this infra server, but right now I cannot access. To make it accessible from the internet, we have a firewall which is attached to the India office. So this firewall is going to take care of it. It will say let's see the status of the NAT first. So coming on to pre-routing. Why pre-routing? Because I have to change the address or the destination address of the packet. -p tcp -d port 80. So whatever traffic is coming in the pre-routing chain which is destined to port 80, and you can say that -d, the destination IP address 192.168.1.240 to port 80 -j dnat, change the destination address -2 10.0.0.2. This is the IP address of station 2. And now if I see, I have added a dnat rule which says coming from any IP address TCP port 80 on 192.168.1.240, send it to station 2. And now if I try to open this, it's opening from the internet, like from the infra server or from my web browser. Which is present on the internet. 192.168.1.240. So I am able to hit from the internet to station2.in, which is actually present inside the India LAN and doesn't have any public IP attached to it. Let's see one more example of the same, where if we want to assign a different port to it, like example of port forwarding. You may have, okay, I'll give you one more example. If config eth0 colon 1 192.168.1.239. So what actually I am doing, I am assigning one more virtual IP address to it, and whatever traffic is coming on the IP address 192.168.1.239 on port 8080, that is to be sent to 10.0.0.2 port 80. So what it says, any traffic coming from the internet coming to IP address 239 on port 8080, send it to 10.0.0.2.80, which is web server. So I just open new tab, http 192.168.1.239 colon 8080, and here you see that I am able to reach to the station from the any public IP address. So this is how port forwarding works. So this is an example of destination network address translation, because we are changing the destination of the packet that is coming. And where do we change the destination? Before taking any kind of routing decision. If we are talking about post routing, we change the source network address translation, or we do SNAT. Okay, so let's talk about a scenario where we want to assign a specific public IP address to any machine. So let's talk about the station. I want to assign it a public IP address. Okay. Third is public IP address to a machine in LAN. So what we are going to do is, till now, what is happening? If I try to reach telnet 192.168.1.205 netstat minus pant grep 80, here I can see that the connection is getting established from ETH0 interface of the firewall. I want to assign it a different IP address, so whenever a traffic is coming from station 2, it is rather going to make use of a different IP address, and I am going to assign it the IP address 192.168.1.238. Fine. So what should I do? Let's come on to the firewall and say iptables minus I post routing minus s coming from 10.0.0.2 iptables minus I post routing minus s minus j, change the address, or in post routing, sorry, we change source address. Post routing minus j snat minus minus 2 source 192.168.1.238. So iptables minus t nat, sorry, I forgot it. So we have added a rule for SNAT that says whenever the traffic is coming from 10.0.0.2 going anywhere, mark it as a source from 192.168.1.238. The other thing that should happen is there should be a virtual IP address assigned to it with the same IP 192.168.1.238 up. So now If I try to repeat the same thing, there is no connection to port 80. I am going to open it. So here you can see that the connection to the web service on infra is coming from 192.168.1.238 rather than 1.250, because I created an SNAT which says whenever the traffic is coming from station 2 and reaching to the internet or any public IP address, it should make use of 192.168.1.238. So this is how SNAT works. Okay, so the other part is if you want to assign a static IP address when the traffic is coming from internet, that is DNAT. So I'm going to create a rule in pre-routing chain -i pre-routing -d any traffic coming to the post routing and the destination of which is 192.168.1.238. Do the destination netting and send it to destination 10002. So what is happening is I am also creating a pre-routing rule which says any traffic coming to the destination 238, destination NAT it to 10002. So what it says, you already created SNAT which says anytime I am going to internet, I am going to make use of this IP address. Now this DNAT says whenever I am trying to access or whenever I am trying to reach to the IP address 238, the traffic will actually reach station 2. So let me try it. 1.238, and here I am able to reach station 2.n. Even I can do SSH to it, and finally I'll reach station 2. So what actually is happening using these SNAT and DNAT rules? We have specified that SNAT says whenever I am trying to reach to the internet, I'll make use of IP address 238. DNAT says whenever anyone from the internet tries to access the IP address 238, it has to reach to the destination 10002, which says a static IP address or a static public IP address is assigned to a station which is inside your LAN. So okay, we are done with pre-routing, post-routing, DNAT, SNAT. So okay, so these are the fundamentals related to IP tables. Please do let me know in case there is any concern. Okay, final thing is after you are done with everything, do service IP tables save. So yeah, thanks for listening and viewing the video. Have a good day. I would really appreciate if you could please let us know your queries and concerns so that we can make the videos better. Thanks for viewing the video. Have a great day.